So I created a project around Restic. Restic is a software backup tool which is pretty fast. It's very reliable. It's just a executable. It operates similar to Git. So it has a repository and the content is encrypted. It also provides several features such as deduplication. And I'm using Restic for my backup purposes for over a year now without ever having any issues with it. So since I have some time on my hand, I decided to create a new project just in order to play around with technologies I'm not familiar with. And the Restic dashboard is the outcome of this. As you can see, the Github page here provides 4 folders. Backend and frontend are obviously the software portions of this application. FS is an abbreviation for file system. It just contains several scripts which allow you to set up some Restic repositories just to play around with Restic and to have a set of repositories used for testing. And install is just a collection of scripts in order to generate a distributable artifact, which can then be used to install the Restic dashboard as a service on Linux systems. And just to have a glance at what's being created here, here is a Restic dashboard in action. Here you can see all my backups provided as cards. Each card provides a list of the oldest and the youngest snapshot. And as you can see, the background color is green, which obviously indicates that it was successful. Let's assume you have configured the time for an erroneous backup to 1 day. So if this would be overdue for over a day, this card would be displayed with a red background. Obviously, this dashboard needs to refresh, so that's the reason for the slider here, which simply ticks down, and when it reaches the end, the complete page will be re-rendered and the current status will be fetched from the backend. Okay, here we are having the checked out repository. And as you can see, you will find those aforementioned folders, backend, frontend, FS, and install. And at first we're going into the folder FS, file system. So you can see there are only shell scripts. The readme.md is for your is a helper for you. And the most important script in here is the common sh, this one. Just checking it out here. So what you can see here is you have a set of some pre-configured repositories. You have 4 passwords. Those are just UIDs here. And those are the repositories that will be used here for this demonstration. And similar to that, we're having some content directories, which are defined here in arrays. And other than that, you will only find here the bash functions wrapping some Restic functionalities. As you can see, you always specify the repository and the password. You can provide those functions as command line parameters as well. I've just used here the environment variables. And since I don't want to use those artificial repositories for the Restic cache itself, therefore I always provide the option no cache here. And you can see here init obviously means the Restic repository will be initialized, and backup is just creating a new snapshot with this directory. Obviously those are the directories which are stored in which are generated here as well. And the snapshots just show all the snapshots that are available, with the distinction that the snapshots JSON version provides a JSON representation. As a side note, all commands allow to provide those the JSON option to get the output in JSON format. So let's start here. As you can see, there is no directory in here, so I'm just creating random files. So this went quite quick, and now you see there is a new folder, content, and this new folder contains several directories, and those contain several files of different sizes. This is just random content copied from def random. So this was the first step, and now we can create some repositories with the init script. And the init script will just create a repository for all entry which we had before, which you could see in common sh. So we will have all those repositories and some with some snapshots. So you can see here now there is additional directory backups. And if you have a look at it, those are the names of the repositories. And now we have a look into the repository itself. And you can see it has a well-defined structure. This structure in general is provided by the Restic developers themselves, so you aren't logged in as everything is open source here. And one note here, there is a logs directory. Whenever Restic tries to perform some operation on a repository, it will create a log file in there. This is just a note for future reference. So now we can try out all those other commands here. We can run backup sh, which will generate the backup. And we have 4 Restic repositories, so you can use an index between 0 and 3. I'm using just 3 here. And we have 2 subdirectories in content, which allows us to select one directory which is 0 or 1. So this is the way we can run the backup here. Doesn't look very nice, but because everything is pre-configured in the common sh, but I think you get the gist. And if you want to have a look at the snapshots that are currently available, you can just use the snapshots sh command and provide a repository of which you want to see the snapshots. Here you have a nice text view, but usually what's more helpful for the development process is a JSON representation. And here you can see the JSON representation of this. Each record represents a snapshot. So these are all the snapshots currently provided within this repository. Okay, so here we are in the backend folder, which provides the Python backend, because I could use a refresher for Python. At first we were going through some uninteresting stuff which is used in here just to get some sort of overview, and then we're going to the meat of the software. First of all, I'm using virtualenv as a virtualization for the virtual environment. Here you have a declaration for setup, and then you have a folder structure, source main test, where the test obviously just contains some test code, and main contains the most functionality, the application itself. The entry point is obviously main py. I generally use always a dedicated exception, so therefore you have a restic-exception in here. And if you can see here, the main function here starts with some administrative stuff. We're setting a process title, which is easier to for tools like top. Rather than seeing a command line with Python blah blah blah, you can see the process itself. And then you have a registration of a shutdown function for this application. And then the main function will be called. And as you can see, the main function consists of this portion here, where we're loading the configuration here and doing some configuration stuff. Here is an option where we're killing the application, so you can call this backend with a kill flag, and if it's being called with a kill flag, it allows you to kill a potentially existing instance, which is needed for the service functionality. And here we have the PID handler, the process ID handler, which essentially runs the Restic dash, which contains the main functionality in here. The PID handler is placed here in utils. It's doing nothing else than creating a process ID file when it's being entered and deleting the process ID file when it's being closed. This is where the kill function allows to get the process ID of a potentially running instance in order to shut it down. So before we're going into this Restic dash function, I will go into the load configuration function here, which is used to load the configuration itself here. And as you can see, this load configuration loads the YAML file. This load YAML function is called in here in IO utils, and it's doing nothing else than deserializing data classes. The configuration itself is stored in config.py, and you can see I'm using data classes and data class JSON, which allows to specify those objects with the corresponding properties. So those can be used in the configuration file. Typically, this will be used with a JSON configuration, so the functionality will be serialized into JSON. But what happens with the data classes, it generates synthetic functions such as from dictionary and to dictionary, and I'm using this to load the class object from YAML, and then I'm passing this dictionary into the from the class. So we generally don't need to use the JSON format. We can use the YAML format, which I prefer, as you can provide various comments in a YAML file, which isn't as easy in JSON. So this helps to provide a nice documented configuration file. This is essentially what's happening in here. And the functionality, you can just have a look at the corresponding data structure. So settings matches to the object CFG settings, and you can just see what those options mean. If I provided a default here, this means you can omit those values. So those values have defaults which are preset. I just placed them in here so you have already something to see. There are some generic stuff such as origins, which is used for cores if you're in the development process and you want to run the frontend on a different port, for instance, or if you want to provide a different context path so you don't have to provide it to the root. And then you have some informational block for configuration for the frontend. Obviously, you could provide some front-end configuration options in the .env files in the front-end application, but this would mean you would have to provide some more varieties when it comes to the front-end deployment. And I prefer to have the front-end loading the configuration from the back-end configuration file. So there is one configuration file for everything. After all, the front-end will be bundled together with the back-end. So those are just some configuration options, and the most important configuration option is the backups, which allows to provide those backup settings. This is one backup, one repository information. And this is the key, which is used to be displayed in the dashboard. The password, the repository, obviously, and the amount of seconds, which indicate when a backup is considered to be overdue. One note here for the password, I usually use the passwords directly, so I'm providing the password in here, but you can provide a file itself if you want. So you can provide the password in a different file and just place the file location in here. If we go back to the main function here, the load configuration is altering the configuration itself while it's just checking for all those passwords, and if the password is a direct password and not a password file, it will generate a password file, because the Restic Pi wrapper, which is used for this application, requires to use password files. So this is just the configuration stuff, which isn't very interesting here. And now we're going to the Restic dash function, which is essentially the meat of the application. The Restic dash function starts the backup manager and the Flask thread. First of all, we are going into the backup manager. The backup manager uses the backup data object as in order to store the configuration settings. So similarly to the configuration, we are providing the data structures which will be delivered to the front end through data classes here. And as you can see, this is the outcome that we had before when we showed the generated JSON output for the snapshot using Restic. This is a snapshot, and in order to provide some additional information such as the name and the amount of time, which indicates an overdue backup, we're providing this wrapping object as well. So backup data is essentially managing those records. As you can see here, this is the key is the name of the backup and the corresponding data structure. And essentially it will be initialized with all those records. And when you call update function, it will be updated as well. So whenever we recognize a change in a repository, we can call update. And as you can see here, the Restic Pi wrapper will be configured and invoked, and we are getting here a list of the JSON results. These are the JSON snapshot information, which then will be deserialized and put into this backup infos object. It might be the case that we're not having a directory yet, because if you have your repositories on a remote network and you're binding it somewhat later, we're having the option that we're just setting up this data structure without any records, and this can be whenever update is called afterwards, when, for instance, when the remote repository becomes available within the file system, you can just call update in order to refresh the information. So essentially backup data is just a data structure for all those backup information with this function which loads this backup information through Restic. And here you have the backup manager, which is essentially just a thread. The thread which will launch an observer using the watchdog library. And what it does, as you can see here in the function, it checks for it monitors the logs directory, because as I've mentioned earlier, the logs directory will be altered when an operation happens, and it will monitor this logs directory, and when it recognizes such a change in there, a deletion of a log file, which means Restic is finished in there, it will mark this configuration as dirty, so indicating that it has to be reloaded. We're not updating this record directly, because it might be the case that there are some operations running in quick succession, and we don't want to run this the Restic Pi functionality unnecessarily often. So that's why there is a grace period. So if you if we're watching here we are registering our listening for the changes. Here is our main thread, our main thread functionality. Here we're registering potentially configurations that have not been registered yet, because as I mentioned earlier, it might be the case that some folder directories are coming online after some time. So this is some helpful functionality, so you aren't forced to have all those repositories available when the service starts. And here we're fetching all those records which are outdated, which have not been dirtied for a certain amount of time, which is obviously configurable. By default, it's 10 minutes. So but you can reduce this time if you want. And if there are some, they will be clear, so they aren't dirty anymore. And here we are updating our storage. And what happens in here is that the storage is accessible through those helper functions here, which is just passing the information. And if we go back to our main function, here we are having the views, which just provide those configuration information. So you can see here all Restic backup information from the backup manager, and thus the backup data will just be put out. And as you can see, here is a toDictionary function, which is used to generate the corresponding dictionary. So this was the first intro to the backup manager functionality, and now to the setup Flask functionality. It uses a static directory. The static directory is optional, and essentially it's a directory where we are providing our front-end code in. And as you can see, it's using here a stoppable Flask helper. The stoppable Flask is just a thread which runs the Flask application itself, wrapped in Waitress, obviously. And the reason for this running in a different thread is the fact that we don't have access to the shutdown functionality from Flask. So we're using a thread in here which allows us to stop the thread and thus Flask itself. So it's just something in order to have some convenience in here. And what we're doing afterwards is just registering the blueprints. Here is the API blueprint which provides our API endpoints. Here are the endpoints which will be mounted using the context class /API. And if we are having the static directory which provides our front-end code, we're registering a corresponding blueprint while providing the content from the front-end directly below this context path. So this is what essentially happens in the application. What's otherwise notable here is that I'm using PEX, and here's a little script PEX build sh, and this is essentially a script which allows to generate a executable of a Python functionality. So I'm quickly removing here the corresponding build, and this is just bundling every dependency together with every dependency into one executable. The only thing that's not being added in there is the Python interpreter itself. So if you're finished, you got the fpex, which is configured in the shell script, and you can just run it like a normal executable. I'm just showing this is essentially the backend, and here I'm just launching the backend with a help function, so you can see the command line which has been configured in there. So I hope this introduction was sufficient. Otherwise, you can have a look at the README file, which provides some, hopefully, enough information to enter it. Otherwise, other than that, it's a pretty standard application. It's a pretty standard Python application. So here we are in the front-end directory. I'm using pnpm as a package manager, but you can use npm or yarn as well, adjusting the corresponding command lines. I've created this project using the quick start instructions you can find on Flowbyte. Flowbyte is a UI framework based on Tailwind CSS, which is pretty nice to use, and you can see a lot of components and how they have to be set up on the Flowbyte page itself, so I really can recommend this page. And primary other technologies I'm using here is obviously Svelte5 and Vite. Vite is the build system used here for this project, which will be set up as part of the Svelte configuration. And I'm using Svelte5, even though it's just a preview, but I figured it works very well and it makes the code base much more readable. So I really appreciate the work of people like Rich Harris providing such a great framework, especially since I'm typically a backend developer, so dabbling into frontend isn't much fun for me usually, except for Svelte5. So as you can see, you have here a typical HTML file, which is a root, which will be updated accordingly. And here you can see the Svelte variables which will be filled in. This is most of this code is being generated, and you can see I'm going first. I will go through the lib comp directory. The lib directory contains all its types here in this TypeScript file. And as you can see here, I'm using archetype. Archetype is a nice framework, a nice library, which allows you to specify type definitions using TypeScript here. So here is a more interesting example. And you can use those type definitions, first of all, to generate the type itself, but also you're getting a constructor in order to instantiate those types and to validate them. So you get the possibility to check out whether some properties fulfill the requirements or not. For instance, here the short ID is supposed to be of length 8. So if the backend would send a short ID with a different size, you would get an error here. So these are essentially all the types defined in here. And as a note here for the snapshot, I'm just using those properties because we don't show anything else in the front end right now. But in future, we could provide some additional view for all the other properties provided by the backend. So these are the types. And here is the client. I'm currently using the client, the Axios client, rather than Fetch, because in the past, when I used Fetch, I wasn't very satisfied with this. I always try to resort to Axios. Nevertheless, I think the Fetch functionality from the browsers might have a state currently where it might be smarter to use Fetch rather than Axios. I will see that in the future. Axios was just a framework I was familiar with, and therefore it was easy to use for me. And it's just an ordinary client class here, which does a get operation, and any kind of error will be provided to this error handler. There is no pretty error handling in there yet. I'm just dumping the corresponding information into the error handler as a string, so nothing fancy in here. So everything, the get function will always provide essentially a success, which can be either undefined, which means no value was being created because of an error, or as you can see here, it can use the parsed data. As you can see here, I'm assuming an archetype, because if the archetype functionality would identify an issue, it would generate here, it generates a check result type, and check result type here contains either problems or data, and problems is a list of validation errors. For instance, let's say short ID would have a length of 20 or so, you would get a corresponding message that the short ID is invalid here. and that's what's just being passed in here. Nevertheless, as I said before, the error handling is currently not very pretty because this whole project is primarily meant to be run in my own home lab. So as long as no other one is bothered by that, so there's no issue in here. So the client itself is pretty simple, and one of the most important functionalities is here store Svelte5. As you can see, here are some helpful functionalities to manage values in the local storage of the browser. And the most important function in here is a create store function, because this is a function that generates the store itself using the state rune. Runes is a new concept introduced with Svelte5, so you don't have to resort to the old. You can use Svelte4 functionalities, but I really recommend to migrate to runes because those are really powerful and very easy to use. So this rune is just creating the object from the serialized content in case it had been serialized beforehand in the local storage. Otherwise, the default value will be used. And here you have a function setValue, which just removes the corresponding value from the local storage or changes it. And we're returning a simple object which provides functionality to access the value itself or to access an information whether it has been changed, or to change the value itself or to reset it. So those are the functions that allow to manipulate the store. And as you can see here, I'm creating a bunch of stores here which are used across the whole application. Just as a note, this is a pretty generic implementation, so there are some cases where it might be advantageous to use a refined way of a store implementation. Nevertheless, this was the quickest way. And as you can see, I'm here usually as a deserialization function, I'm using JSON parse because everything is stored as a JSON object in the local storage. However, I'm also using for some functionalities those archetype definitions. So this is being processed by archetype, and then I'm retrieving the data object here. This is a point where an error could happen, obviously, because if someone modified the local storage value directly, you might add some issues in there. Nevertheless, for this stage of the application, I don't care about it, so I'm just assuming it will be parsed and validated correctly, and I'm just using the data directly. So this is a collection of stores which is being used in here. And just for the sake of completeness, alert store is just a store for an error message. Application state stores, we're managing two application states, which is display and loading. Loading is a state when we have sent out a request to the backend in order to fetch some information. Usually this should run very quickly, so you wouldn't even notice it, but this is a possibility to distinguish those states. Backup info store is a list of our backup information. This is information that essentially is being displayed in on the dashboard. Config store is a store which provides some information for the front-end configuration. This is a front-end configuration which is being fetched from the backend. And progress store is used for the loading process itself. When we are loading something, we with a timeout. So let's say we have defined a time of 20 seconds. The progress store will be set to 20 seconds, and it will tick down. So you would see a spinner, and you would know if the loading takes too long, the loading will be aborted because of a timeout. Usually that's something you won't see unless you're explicitly delaying the responses from within the backend. So these are some helpful functionalities in here, and here are some components. Footer and Svelte, footer and header Svelte are simple components which are just providing some links and nothing important. They have no real meaning for the application. However, I provided them because in the end, those are areas that might change in the future. So I thought it would be best to set them up beforehand, so there's no much restyling in the future, if hopefully. And here we have one important component, error message view. As mentioned earlier, it uses the alert store, which just contains the string. And if the alert store has been changed, essentially some content has been put in there, this will render the component. And don't be scared by this stuff. This is essentially a copy of the corresponding component in the corresponding alert component on the Flowbyte side website. So you just essentially copied the content from there, refined it according to my needs, which means I've provided the corresponding text, and I've added here an dismiss handler, which essentially just resets the store, so the store will be emptied. So that's all. So nothing complicated here. Backup info view is a representation of a single card, and what it does is it checks at first if we have such an information itself, and if it has at least one snapshot, it will take the last snapshot and will check and verify whether this snapshot has been created in a certain amount of time, whether it's overdue or not. So this is a failed flag for. If there is no snapshot, we're considering it an issue. And depending on the failed flag, we're setting up here our background class, which might either be red or green. And as you can see, this is essentially just a card. Again, this is mostly copied from the Flowbyte website, except for this table, which shows some information regarding the snapshots. Currently, we're just providing the first and the last snapshot because we don't need the snapshots in between. But in future, we might change that. But first and last snapshot is currently sufficient. So this is a backup info view, and here comes the auto reload component. This auto reload component is a slider I've showed in the Restic dashboard. Or to be clear, it has essentially two states, as mentioned earlier. It has a display state. The display state is a slider component which goes from which shows that the time is running out. Or if it's in a loading state, it's a spinner object. And if it's in a display state, and if the display state runs out, you will see here the function load restic will be called. And the load restic function essentially clears the timeout counter, and changes the state. So if when changing the state, the loading portion, the loading spinner will be displayed. As mentioned earlier, the progress store will be set to the timeout, so the user can see how many seconds until the timeout happens. Correspondingly, the timeout will be updated. And here the client will be created and the response will be fetched from the backend. When the backend responded, we don't need the timeout anymore, the progress display anymore for the loader. And we can set the backup info store with an update value and restore the original state that we're displaying the slider itself again. And after that, we're starting a new interval until the next reload of load restic will happen. So essentially, that's why the auto reload will always start again within a refresh. So those are the components in there. So as you can see, there aren't much of any component in here. And now we're going through the routes, which are the pages from Svelte5. Quick look into layout TS. You can see where I've set the flag pre-render, which means as we're using the static adapter, Svelte5 will create all the necessary files for static deployment from all the code base. That's what the flag is for. And if we check in here the layout Svelte, which is a primary layout, you will see it's pretty simple. It's just a div here. It contains a header. The header is the header component and the error message view. It contains a main section. The main section is a page-specific content and contains a footer. So this is where the interesting part comes in. But before we go there, here we have a look at the Svelte script functionality. One thing is that we're here having some data and we're setting up some dictionary, some localization stuff, because we're using Svelte I18N. It's currently not fixed for Svelte5, but it works very well with Svelte5. And we're setting the initial locale to either the query string from the query option lang, or from the navigator. And now the question is, where comes data from? And you can see here's a layout server TS. This is a code portion which would be executed on the server, or to be more precise, this will be executed during the build time. And here is the load function, and the load function simply scans this I18N folder and goes through all the language files. And as you can see, as I've mentioned earlier, I prefer YAML over JSON. So you have all those translations in here. So this has a key general.error for this string. Accordingly, general.connection aborted for this string. And this is being loaded within those from those files and put into the corresponding dictionary with the language code. By convention, I'm assuming the base name from the file is a language code, and this is being provided as a property dictionary. So if you go back here, you can see it will be loaded. The dictionary will be set here by this property. Another portion here is the load config functionality. This functionality will just fetch the configuration from backend, which is meant to be used for the front end. So as you see, the layout is pretty simple and there's nothing very magically happening in here. So the important stuff is here in the page Svelte, and the page Svelte is just using the auto reloader for the refresh of the page. And whenever some change happened to the store for the backup infos, it goes through all those records and just renders it. So nothing else in here. It's quite straightforward. And that's essentially it. I can show you some modifications I've done regarding the standard setup. For instance, in the Svelte config.js, I've defined some aliases because I prefer to use aliases within my import paths rather than relative paths. But that's not really necessary. In the Tailwind config.js, I'm extending the theme for Tailwind because I personally don't like border radiuses. I'm not a fan of it, and I just defined some orange tinted colors here as my primary colors. And other than that, here I'm adding a nesting function nesting plugin, so you can use nested code in here for the CSS. So you could use here nested code. I'm not sure whether it's very really necessary nowadays. Nevertheless, you got it. And that's essentially all those. So there's not much to be gleaned from this. This is the code portion for the front end, and you can just run a build process if you're calling pnpm build, and this will generate a build directory with all the statically generated content in here. Here you can see this is essentially what comes out of it. Okay, so here we are in the install folder of our repository. As you can see, there's currently nothing else in there. You can see there is a build script and the resources folder. If you're checking out the resources folder itself, you can see there are several helpful scripts which will be bundled as part of the distributions, and also the service for the registration in Linux, and an example configuration. Let's just check out the service itself. So as you can see, it's just the name and the description. And here we have a start of the service. We will save all this Restic dash stuff in a directory opt restic dash. Similarly, we will place our frontend content in there, and our configuration will end up here in etc restic YAML. And if we want to try to kill the service, to stop the service, we will call the same configuration with a kill flag. That's essentially just reading out the process ID for the service and invoking a SIGINT for the service, so it can properly resolve all running stuff. So let's just run a build process. And what happens here is that it's calling the PAX build for the backend portion, and it's running the pnpm dev pnpm build for the front-end code, and it's creating everything and writing it into the Restic dash. And here you see the tar.gzip version of it. So now we're going into the Restic dash, which is essentially our distributable folder. And here you can see we have our application, our backend service code, and the front-end code in here. And if you're providing it to your machine, if you're copying this archive here to your machine, you can unzip it, create this Restic dash, and you can run this install script, which will install the service onto your system. Then you can make the necessary configuration in etc restic dash and restic dash YAML to configure your backups, and that's it. You get some instructions how to restart the service and how to how to reload the daemon, the information for the daemon. But other than that, you're ready to go. You can query the Restic dashboard depending on your settings, where you have which port you have selected and which context path, if you have selected the context path at all. If you don't like to have the service anymore, you can run uninstall. And in addition to that, if you have an updated version, you can just update. Update is just stopping the service, copying the new files and stopping the service. Obviously, the Restic dash configuration won't be overwritten in there. And that's essentially it. Okay, so here we are in the install folder of our repository. As you can see, there's currently nothing else in there. You can see there is a build script and the resources folder. If you're checking out the resources folder itself, you can see there are several helpful scripts which will be bundled as part of the distributions and also the service for the registration in Linux, and an example configuration. Let's just check out the service itself. So as you can see, it's just the name and the description. And here we have a start of the service. We will save all this Restic dash stuff in a directory opt Restic dash. Similarly, we will place our frontend content in there, and our configuration will end up here in etc restic YAML. And if we want to try to kill the service, to stop the service, we will call the same configuration with a kill flag. That's essentially just reading out the process ID for the service and invoking a sigint for the service, so it can properly resolve all running stuff. So let's just run a build process. And what happens here is that it's calling the PAX build for the backend portion, and it's running the pnpm dev pnpm build for the front-end code, and it's creating everything and writing it into the Restic dash. And here you see the tar.gzip version of it. So now we're going into the Restic dash, which is essentially our distributable folder. And here you can see we have our application, our backend service code, and the front-end code in here. And if you're providing it to your machine, if you're copying this archive here to your machine, you can unzip it, create this Restic dash, and you can run this install script, which will install the service onto your system. Then you can make the necessary configuration in etc restic dash and restic dash YAML to configure your backups, and that's it. You get some instructions how to restart the service and how to how to reload the daemon, the information for the daemon. But other than that, you're ready to go. You can query the Restic dashboard depending on your settings, where you have which port you have selected and which context path, if you have selected a context path at all. You can also use this update script, which essentially just stops the currently running service and copies the current application files to the opt Restic dash directory, and then stops the service, then restarts the service again. For obvious reasons, the Restic configuration will not be changed at this stage.